isn't that the same thing as multiplying by 1/16?
You have 16 y squared over 25.
Oh.
That's why it's weird. Oh.
Y squared over 400.
Yep.
Minus
That's how that works.
X squared over 2.
Very good. What is it, 400?
Yeah.
Yep. Minus x squared over 256.
That's how it works. From there, it's really, really easy. Okay? We okay on that then?
Yeah.
Hey, how'd the SAT go, girls?
Your girl.
Air 5. Yeah. Yeah. You're not as excited as that was. I never took the SAT. Did you know that? No. I took the ACTs, yeah. Back in my day, we had the microphones. But most schools in the Midwest didn't care about the SATs. It was just schools on the coasts that worked at the SATs. So I wasn't going there. So I just did proper. So yes, ma'am.
Why never going to touch the videos?
Probably tomorrow. I thought about it, but then I realized, you know what? If we do get through this stuff, what I want to get through today, then we can kind of be a little bit easier tomorrow. I'm doing that one next. Do I have to go through all the steps in this one? We're okay with steps. They're pretty quick, right?
Yeah.
Can you give us graph paper?
I don't want you to have graph paper. The reason I don't want you to have graph paper is because I don't want you to rely on it. I want you to be able to visualize and be able to mark your own ranges and stuff. Because next semester, or when we start doing other graphing stuff, we're eventually going to graph exponential stuff. We're going to graph square root stuff. We're going to graph sines and cosines and things. But I want you to be able to, I want you guys to be able to come up with your own set ranges and things like that, so that way the graphs, this curve doesn't change for a sine graph.
Oh, so it's not at 0.
Right, it could be over here, it could be up here, it could be there. But what happens is I want you guys to be able to come up and develop your own breakpoints. And by doing this now, by learning how to just fudge a graph, if you will, it's so much cleaner later on. Okay. So when we get to this one, this is a tricky little sucker. All right. First thing you have to worry about is dividing by 25. Pretty easy. We can do that. So we divide everything by 25. We're going to get x squared over 25 minus 9y squared over 25 equals 1.
So we multiply by 1/9 over 1/9.
Yes.
Yeah. You will see this next trick quite often in the conics stuff when you have to get rid of some sort of a multiplier, a scalar that's in the numerator. When you have to get rid of this, we use this trick. We're still going to multiply everything by some factor of 1, but our new factor of 1 is just going to look really, really, really weird. I like because what's 1/9 divided by 1/9?
1.
1. What? Because what I'm doing is I'm multiplying everything here by 1, and as I distribute through, what's 1 times, when I distribute through all these things, really the only thing that's going to change out is that it allows you to get rid of this as it simplifies itself through. Okay? This is the weird trick. It shows up, I think there might only be 3 or 4 problems to this entire, which one was it? I don't think there's another one today's. I think 41 seems like. Yeah, what happens is, as you distribute stuff through, the first part, 1/9 over 1/9 is 1. So it's still going to be x squared over 25, okay? The next one then, as it distributes through, you're going to use them in terms, because that's how you get rid of this. Because if you distributed through, if you rewrote this out to the first part, you have 1/9 over 1/9 here. What's 1/9 over 1/9? 1, so that's why you don't worry about it. When I do that here, 1/9 over 1/9,
You keep yourself.
this one simplifies out, but this one doesn't. That's why this works. And then we do the 1, it's just 1. Okay? This is a very, very weird trick that you will probably only ever see in this unit, in this chapter, or whatever we call it. We rarely, if ever, have to multiply across by a complex fraction. I don't think we ever do it again, aside from in comics, okay? It's just a weird little trick. From there then,
Should we expect to see a question like this on the test papers?
maybe.
Okay.
But now that you know the trick, the rest of the problem's pretty quick then. Because you know it's an x squared hyperbola, so it's going to go left and right. You know your a squared value is 25. Your b squared value is 25 over 9. So if b squared is 25 over 9, what would b be?
5/3.
5 over 3. So it works out real quick. Okay? So it's not like it's going to be horrible. When you find your value of c, you're just using your calculator with the fraction bar, and it's going to calculate all of it for you. It's not that much crazier. And that's, again, why I don't want you guys to have graph paper, because then you'd be sitting there going, where's 25/9? You know what I'm saying? When you can just kind of say, oh, it's approximately there. It's easier. Okay? It's not binding you by some physical domain range. You're interpreting it for yourself. Okay? Does that make sense on the trick for that one?
Wait, can you just say the steps of it again?
For the trick? Okay. So what happens whenever you stuck with some scalar multiplier that's in the numerator of a conic, whether it's an ellipse, hyperbola, parabola, this works for all of them. What we're going to do is multiply everything by some factor of 1. By doing that, you're going to multiply by the reciprocal of the constant. 1/9 over 1/9. If I distribute this into all of this, the long-winded way of seeing it would be 1/9 over 1/9 times x squared over 25 minus 1/9 over 1/9 times 9y squared over 25 is 1/9 over 1/9 times 1. These are all monomials. There are 3 of them. Monomials are numbers and variables and all that kind of stuff put together via multiplication. Within monomials, you may simplify. So that's why I can sit there and simplify 1/9 over 1/9 is 1. Here, it becomes 9 over 9 y squared over 25 over 9. The 9 over 9 part simplifies, whereas the fraction stays to the bottom, and then the last part just becomes 1. That's how that trick works. Okay? Whether it's a 9 in the numerator, a 4, a 7, a 63, whatever. It's a crazy little math trick. Those math people. Crazy. Okay, let's add a little bit more to our notes. We'll add to these problems later. We need to know how to what I had this.
Wait, are you still hyperbola yours?
Yeah. Oh, I guess I didn't. Oh, that's silly. Why didn't I do that? Oh well. Where's the book? So it's what, 10. What happens then when you're given let's write the equation. Yes, ma'am.
How would you write the slope when the rise over run is like 5/3 over 5?
Think of it this way. If it's 5/3 over 5, that's the same thing as 5/3 divided by 5, which is the same thing as 5/3 times 1/5. So it becomes 1/5. Also, if you have to calculate your slope, and this is, hey guys, this is a great question. Sometimes if you have to calculate your slope and you've got that really crummy fraction, like a complex fraction, that's what they're called. They're so, the terminology is so complex I forget. Alpha y equals 5/3. That's not the right button. Alpha y equals 5/3. And then I can do alpha y equals over 5. Calculator will do it.
You can also do math left enter to get Wait, why did you need that?
Parentheses.
Wait, we just did another problem. I was writing something down.
She had Emma had a question about how do you write this, how do you solve for slope if it's 5/3 over 5? If the rise over run when it was a funky fraction. It's my garage band, funky fractions. What? All right, so write the equation of the hyperbola, given the following information. We have foci and vertices. The funky fractions in the foci. Yes, that's an even better name. Track.
So where did you get 1/5?
When you divide by 5, it's the same thing. When you divide by 5, it's the same thing as multiplying by a fifth. Multiply by the reciprocal. Divide by 2 is the same thing as cutting it in half.
Oh,
We're going to add some to it. So, hyperbola. Let's figure out which way this is going. That's the first thing you want to do, is decide which way this is opening. Foci, -8, +8. Vertices at -7 and +7. Which way is it opening? Left and right. It's opening left and right. It's doing that. How do I know that? Because remember, vertices always open up towards the focus. No matter what the conic is, vertices always want to look at the focus. Always, always, always. So we know it's the left and right hyperbola, which means is it an x squared first or y squared first? X squared, good. So we'll start with that. We know that's left and right, so it's going to be an x squared over a squared minus y squared over b squared equals 1. We know some distances. We know that the distance from the center to the vertex is a. Well, from center to vertex is how far? 7. So a is 7, which means a squared is? Good. We also know the distance from center to focus is what? Is what? Is 8. Is it 8? Is it A, B, or C? C, because there's a C in focus. So that's 8 C squared, 64. So B is going to be 49 plus what is 64? 15. Very good.
Wait, I thought that B, I thought that C was A plus B.
It's A squared. C squared is A squared plus B
Yeah,
squared.
yeah, that's what I was.
That's why we figured out what A squared was, and we figured out C squared.
Well, shouldn't you figure out A squared and then B squared?
squared equals 15 times 1.
That's how you find those out. That's how you work with those to find those out real quick. Very similar to how we did that with the ellipses. When we did the ellipse stuff, we kind of rough sketched where things were going to decide whether or not it was vertical or horizontal, knowing that the value from center to the vertex is A, center to co-vertex is B, center to focus is C. So your final answer here would have been x squared over 49 minus y squared over 15 is uno. Uno. Hola, ¿cómo estás?
Do you want us to graph it out, or do you want us to just do like a rough graph?
When it says write the equation, I don't expect you to graph it.
Okay.
Honestly, if you don't need to graph, you don't have to.
Okay.
I think by the time we get to once we start getting to the shifted stuff, once you recognize that if it's a hyperbola, you notice that they're all sharing the same y value, it means it's horizontal. It means it's going to be like that. You see they're sharing the same x, it'll be that way.
Okay.
Sometimes it's really all you're going to need to do. I like doing that because it's visual, plus it's only the second day we're doing it, so it's kind of nice to fill it in.
Yeah. Okay.
A lot of times when I ask you to graph and do the whole shebang, I'll write out, do the whole shebang.
Okay.
What? The shebang? Yeah, I would, wouldn't I? Just like Mr. Fontana needs a part-time job. The test question?
Oh, yeah. Yeah, you made.
I made some great. I love my word problems. Were so awesome. Let's see. Versus. Okay. Tonight, what I want you to do then is, let's see, because I want to give you guys your tests and talk about them.
Oh, yeah. Both tests?
Yeah.
Trav, are you still running something
Pick a number 1 through 10.
7.
Do odds.
Wait, what?
51 to 63 odds. Same page. 51, 63 odds. Oakley dokley. What I started with here is I threw in a couple more where you're going to do the whole shebang. And then the rest of them are, the last 4 are write the equation. Okay? Obviously with the book material, a lot of times what they do is they just give you foci and vertices because technically the co-vertice doesn't exist. But I might still say, hey, here's a co-vertice. If I give you a co-vertice and a vertex, it's really, really easy. It's very easy. Let me get you guys test stuff.